Lesson: Language models and their applications. Language models have emerged as pivotal components in the realm of artificial intelligence, particularly within the subset of natural language processing. These models, which are designed to understand, generate, and manipulate human language, have revolutionized various sectors by enabling machines to process and comprehend language in a way that mirrors human interaction. The surge in computational power, coupled with the availability of large datasets, has facilitated the rapid advancement of language models, enabling them to perform tasks ranging from simple text generation to complex language translation and sentiment analysis. The development and deployment of language models are underpinned by several key frameworks and tools that allow professionals to harness their potential. One of the most prominent frameworks is TensorFlow, an open-source library developed by Google Brain. TensorFlow provides a comprehensive ecosystem for building and deploying machine learning models, including those for NLP. It offers high-level APIs like Keras, which simplifies the creation of neural networks through a user-friendly interface. TensorFlow's flexibility and scalability make it an ideal choice for developing language models that can be deployed in production environments. Another essential tool in the language modeling toolkit is PyTorch, an open-source machine learning library developed by Facebook's AI Research Lab. PyTorch is renowned for its dynamic computation graph, which allows developers to modify the network architecture on the fly. This feature is particularly useful for NLP applications, where the input sequence length can vary. PyTorch's ease of use and seamless integration with Python make it a preferred choice for researchers and engineers aiming to experiment with and deploy language models quickly. One of the quintessential breakthroughs in language modeling is the development of the transformer architecture, introduced by Vaswani et al. The transformer model eschews the recurrent nature of previous architectures like LSTMs and GRUs, instead relying on self-attention mechanisms to process input sequences. This innovation has significantly enhanced the ability of language models to capture long-range dependencies and context, leading to state-of-the-art performance on a wide array of NLP tasks. The transformer architecture forms the backbone of many advanced language models, including BERT and GPT. BERT, developed by Google, is a pre-trained language model designed to understand the context of words in a sentence by examining their bidirectional relationships. BERT's ability to consider both the preceding and following text when analyzing a word has set new benchmarks in NLP applications such as question answering, named entity recognition, and text classification. By fine-tuning BERT on task-specific datasets, professionals can leverage its pre-trained knowledge to enhance performance on domain-specific NLP tasks. In contrast, GPT, developed by OpenAI, is primarily focused on text generation. GPT employs a unidirectional approach to generate coherent and contextually relevant text. Its architecture enables it to produce human-like text that can be used in applications such as chatbots, content creation, and interactive storytelling. GPT-3, the latest iteration, boasts 175 billion parameters, demonstrating the immense scale and capability of modern language models. By utilizing GPT-3's API, developers can integrate sophisticated text generation features into their applications without the need for extensive computational resources. The practical applications of language models extend beyond theoretical research, offering tangible benefits in various industries. In healthcare, NLP models can analyze clinical notes and patient records to extract relevant information, aiding in diagnosis and treatment planning. For instance, IBM's Watson Health employs NLP to interpret medical literature and provide evidence-based recommendations, enhancing clinical decision-making. In finance, language models are used to analyze sentiment in news articles and social media, providing insights into market trends and investor behavior. By implementing sentiment analysis models, financial institutions can gain a competitive edge through timely and informed decision-making. Developing and deploying language models requires a strategic approach to overcome challenges related to data privacy, model interpretability, and ethical considerations. To address data privacy, professionals can employ techniques such as differential privacy, which ensures that the inclusion or exclusion of a single data point does not significantly affect the model's output. This approach enables the secure use of sensitive data in training language models without compromising privacy. Model interpretability is another critical challenge, as language models are often viewed as black boxes due to their complexity. Techniques such as SHAP and LIME can be employed to uncover the decision-making process of language models. These tools provide insights into which features influence model predictions, allowing professionals to build trust and accountability in AI systems. Ethical considerations in language modeling encompass issues such as bias and fairness. Language models trained on biased datasets can inadvertently perpetuate stereotypes and discrimination. To mitigate these risks, it's essential to curate balanced and representative datasets during the training phase. Additionally, techniques such as adversarial debiasing can be applied to reduce bias in model predictions, promoting fairness and inclusivity. The deployment of language models also necessitates robust evaluation metrics to assess their performance accurately. Traditional metrics like accuracy, precision, and recall provide valuable insights, but they may not capture the nuanced capabilities of language models. Advanced metrics such as BLUE for machine translation and ROUGE for text summarization offer a more comprehensive evaluation of language model outputs. In conclusion, language models have transformed the landscape of natural language processing, offering unprecedented opportunities for innovation and efficiency across diverse domains. By leveraging frameworks like TensorFlow and PyTorch and architectures such as transformers, professionals can develop and deploy sophisticated language models to address real-world challenges. The integration of language models in sectors like healthcare, finance, and beyond underscores their practical utility and impact. However, to fully harness their potential, it is imperative to address challenges related to data privacy, model interpretability, and ethical considerations. Through the adoption of best practices and cutting-edge tools, professionals can enhance their proficiency in language modeling, contributing to the advancement of AI technologies while ensuring ethical and responsible deployment.